Here we go. Missed on the little first part, but we get the second part of it. So, like I said, for rules for counting our sig figs, we want to circle our non-zero digits as they are always significant. Rule number 2, I want to circle all trapped zeros. Now, what I mean by trapped, I mean that these are zeros in between non-zeros, as they are always significant. Now, if I'm making a bunch of caveats, something's always this, always that. That means at some point there's some kind of step that's going to be an if-then answer. And we've hit our one. Rule number 3, we need to circle each trailing zero only if the number has a decimal. No decimal, not significant.
So that means like if 500 has like 1 and then like 0.500 like 3.
And lastly, number 4, any leading zero are never significant. 2 steps. Step point, always significant. Step 3, if then. Step 4, those zeros are never significant. Using these 4 steps, I want you to tell me how many sig figs do we count in our number that we started with at the top. How many sig figs do you have? All right, we got an answer for 5. Do I hear another? Got an option for 6. I'll take one more. So we've heard 5. We've heard 6. How many sig figs do you think we have in our answer? Let's find out. Step 1, we need to circle all our non-zero digits as they're always significant. What are my non-zero digits in my number here? 2, 3, 7. Perfect. Step 2, I need to circle any trapped zeros that are caught between non-zero digits. Do I have one?
Yes.
Where is it?
Between 3 and 7.
Between 3 and 7. Perfect. Step 3, circle each of the trailing zeros only if there's a decimal place. Do I have a decimal?
No.
Do I have a trailing zero?
No.
What's that? It's a 0. That's what trailing means. Trailing means at the end. So do I count it as significant? Perfect. Step 4, leading zeros are never significant. So what do you think I'm going to do with those 2 leading zeros?
Don't count them.
I'll cross them out as I don't count them. So I do 1, 2, 3, 4, 5. My answer has 5 sig figs.
So is the leaders like before the non-zero?
Leading zeros are any zeros in the beginning of my number. Trailing zeros or any zeros at the end of my number.
Okay.
Let's do 3 of them real fast. I'm going to give you 3 numbers, and I want you to tell me how many significant figures they have. $74 meters, 740 meters, 0.7040 meters. Use your steps that you just picked up to identify which one, to identify how many sig figs they have. When you're done, you're going to write your answers on your whiteboard. You're going to show them to me.
How many sig figs does each one of these have?
You're counting them for me. You count me how many sig figs are in 74 meters. You tell me how many sig figs are at 740 meters. And you tell me how many sig figs are in 0.7040 meters.
So it's just like how you, what's it called? If you try to do it in scientific notation plus the zeros at the end.
We're going to get there in a second. Scientific notation is a different thing.
Well, like you can, like you don't add the starting one because like if I did that in scientific notation, I would just have 7 like the last one there. I have 7.04, but then plus the zeros at the end. Like, you know what I mean?
I think I know what you're talking about.
And then the 740, you can write that in scientific notation as 7.4. Because there's no.
Right. Let's see what you guys got. Show me your whiteboards. Let's see what we got. Let's see if we're on the same boat. All right. So everyone seems to be pretty good with number 1. Most people are good with 2. And looking around. Okay. We're pretty good consensus for number 3. Good. All right. Let's do it. So. 74 meters. Step 1, I need to circle all my non-zero digits, right? 1, 2. Do I have any other digits to work with?
No.
How many numbers did I circle? 2. Perfect. 740. First step, circle all my non-zero numbers. 1, 2. Step 2, trap numbers. Do I have any trap numbers?
No.
Step 3, trailing numbers. Do I have trailing numbers?
Yes.
Zeros. I do. Do I have a decimal place?
No.
Do I count it? No. Do I have any more numbers to worry about? Nope. So that's 2. All right. So we have pretty strong consensus at 7 and 4 non-zero numbers. That's step 1. Step 2, trap zeros. Do I have trap zeros?
Yes.
Where? Between the 7 and the 4. Trailing zeros. Do I have one?
Yes.
Is there a decimal place? Yes. Is it significant?
Yes.
Perfect. Leading zeros. Do I have one? Are they significant?
No.
What do I do with them? Cross them out. Count my circles. 1, 2, 3, 4. Significant figures. So let's talk about rounding with them. So to round with them, we're going to go straight to the homework. Right now, you're going to be doing 5. You're going to do from 5 to 9, and then you're going to flip your paper over, and you're going to be wrapping up 10 to 14. That's going to be your homework. We might get into the back page if we have time to talk about how we talk about powers of 10. So that requires us to get through scientific notation, which may or may not be a thing that we do, as we only got like 40 minutes left in class, right? So 5 down. And then all the next page. Okay? So, to help us chip away at those numbers, let's do 6 and 7. Ha! The meme never dies. On the front of our page. So, whew, my goodness. All right. So I need to round 742,396 to 4 sig figs, 3 sig figs, 2 sig figs. So this kind of gears us up to what scientific notation is going to look like for us. So to make life easier, I'm going to rewrite those numbers over here. 7, 4, 2, 3, 9, 6. All right. So before I can start rounding my sig figs, the first thing I need to do is I need to identify the sig figs in my number. How many sig figs do I have in 742,396? 6 sig figs. Everyone's a sig fig, right? So I'm gonna label them from left to right. 1, 2, 3, 4, 5, 6. If I only want 4 sig figs, I'm going to draw a rounding line after the 4th digit. Now, I'm pretty sure that we all know our rounding situation. If it's a 5 or above, it does what? Give it a shove. If it's 4 below, let it go. So, if I want 4 sig figs, my answer only have round to 4 sig figs. Does the 9 push the 3 to a 4? We agree with that, yes? All right. Does that 4 going up affect any of the other numbers in front of it? No. So 2, 4, 7. Now, I'm at a conundrum here. My answer now has 4 sig figs. But if I leave it like this, it's wrong. If I owed you $740,000 and only gave you back $7,400, how upset would you be with me? Very reasonably so. I'm off by a factor of 100. That's crazy. How can I make sure that this 7 stays in the 100,000 spot? How can I make sure this 4 stays in the 10,000 spot? How do I make sure this 2 stays in the 1,000 spot? How do I make sure this 4 stays in the 100 spot? I'm going to add zeros. Why can I add zeros? They are not significant. Great job. I'm filling in the spots. These are technically placeholders. They keep these other numbers where they're supposed to be. These zeros just count as placeholders. So I want you to take a stab at rounding this number to 3 sig figs and then 2 sig figs on your whiteboards. Pretty well. Pretty well. Like this. All right. So we did the first one, right? So we did the second one. So you did a B and a C. So you write it on the whiteboard. So we did 6A. Now you're doing 6B and 6C. You're writing on the whiteboard. So I can see. Come around, check and see how we doing, gang. Gang. Hey, John, this one works. What's that? I didn't want to step on that, so I didn't be prudent. We're very kind of moving to that. Yeah. Step. All right, gang, let's see what you got. In 3, 2, 1, show me what you did. And you've got to be standing up for that one, buddy. I want to see stuff written. Looking good, ladies and gentlemen. Looking good, looking good, looking good in this hood. I am loving it. Loving it. Wait, in the back. Come on. Let me see it one more time. I didn't get a chance. All right, we got it going. We got it going. All right, all right. So, absolutely. If I'm going for 3 Sig Figs, I put a rounding bar between 3 and 4. 3 doesn't push my number up, so that's 7, 4, 2. What am I going to put in the places of position 4, 5, and 6? Zeros. 1, 2, 3. Same thing for 2 Sig Figs. 7, 4. 1, 2, 3, 4. Feeling good about that one? All right, let's look at 7 then. Let's look at 7. Number 7. Mr. Wiseman looking at number 7. All right, number 7. We have a number 0.07284. I need to round this number to 4 Sig Figs, 3 Sig Figs, and then 2 Sig Figs. So my question to you. First thing we gotta do is we need to figure out where my first Sig Fig is. I need to count my Sig Figs and figure out where the first one's at. Where's my first Sig Fig at in my number here? It's a 7, right? So if I was rounding the 4 Sig Figs, where would I put my rounding bar at? Where am I going to put it? At the 4? After the 4. Is there anything to push my 4 up? All right, that means it's already at 4 Sig Figs. What about around to 3 Sig Figs? Where am I going to put my rounding bar at? Between the 8 and the 4. All right, so. Is my 4 big enough to push my 8 to a 9? My 8 didn't change, so that means my other spots didn't change either. Question. Do I put a 0 here? Why would I not put a 0 there? I did it for the other ones. It's not that.
It'd be significant.
It would make the 0 significant, right? And I'm told I got around to 3 Sig Figs, right? 1 Sig Fig, 2 Sig Figs, 3 Sig Figs. Before, when we have very large numbers, the placeholders go in the back. But when we're talking about teeny tiny little bitty numbers, anything below 1, my placeholders are in the front. Because I need to make sure that this 7 is in the 100 spot. I need to make sure that this 2 is in the 1,000 spot. I need to make sure this 8 is in the 10,000 spot. When it's itty bitty numbers, my placeholders is in the front. Placeholders are never significant. When I got super duper large numbers, my placeholders are in the back. Again, placeholders are never significant. So, give me the last one. What's it going to be? Someone just shout it out to me. 0.073. Does everybody see how we got 0.073? We feeling good? All right. So again, let's write this out. Placeholders are never significant. So, we know how to count our Sig Figs. We know how to round our Sig Figs. Let's do some functions with Sig Figs. How do I do math with Sig Figs? How to math with Sig Figs. Because, ladies and gentlemen, something we have to understand is that our calculations that we're going to form can never, ever be more precise than our least precise measurement. And I'm running out of space. So we can never just take the calculator's answer as the final answer. Most of the time, we're going to have to do something with it. Very rarely can we take the calculator's answer as the correct answer. So we have two rules when it comes to doing functions. Oh. And they're split up. Addition and subtraction will follow the same rule. Multiplication and division will follow the same rules. Multiplication and division is the easier one. That our answer should have the same number of sig figs as our factor with the fewest. Now that might not make a lot of sense. So let's put it into practice. If I have a calculator out, and you should grab one real fast, there should be plenty of them around. 5.43 grams times 3.4 grams. Someone do me a favor and punch that into a calculator and tell me what you get.
18.462.
Yep, 5.43 times 3.4. 18.462. So 18.462. What's my unit? Grams what? Grams squared. So, my answer is more precise than both factors in my question. Which one has the fewest? 5.43 or 3.4? 3.4. How many sig figs does 3.4 have? 2 sig figs. So how many sig figs can my final answer have? 2. Does the 4 push the 8 to a 9? So my final answer is 19 grams squared. Oh, sorry, 18. I'm sorry. My mistake, 18. 18 grams. We were all in the same pathway. I just made a small mistake.
Yeah, Mr. Wiseman, when
Yep.
you round them, you round like, you don't round each, like, what's it called, like, tens thing at a time until you get it, you just round the whole thing, right?
I round at the end.
So you, like, instead of rounding the 2 to 0, the 6 to the 6, make that 10, make it
Nope.
5. And then round
Nope, I'm just looking at these two numbers.
Okay.
Because I'm just looking at, is the 4 big enough to push the 8 to a 9? If it's not, this could be 4.99 repeating. That doesn't make it 5 or better, 5 or more, right? Well, let's just look at what that next digit is. Let's do a division one. 6.00 grams divided by 0.05 milliliters. Someone punch that in the calculator for me and tell me what you get.
$120.
120. What's my units? So my unrounded answer is 120 grams per milliliters. Which factor has the least amount of sig figs? 6.00 or 0.05? How many sig figs does it have? How many sig figs can my final answer have? 1. Is a 2 big enough to push my 1 to a 2? What's my final answer going to be then? 100 grams of 100 grams per milliliters. Multiplication division is the easier of the two. Addition subtraction is going to be a little weirder. It'd have to be because I told you there are 2 different types of functions, right? 2 different types of rules. Addition and subtraction will always have the same rule. My answer is rounded to the least precise measurement. Let's do one. 8.4 plus, so 8.4 meters plus 10 meters. Someone punch that into the calculator for me. Tell me what you get.
18.1.
Yeah, 18.4, right? 18.4 meters. Now, these are both measured numbers. Which one has the least amount of sig figs? The 8.4 or the 10? How many sig figs does 10 have? 1. So how many sig figs can my final answer have? Is the 8 big enough to push my 1 to a 2? So what's my final answer going to be then? 20 meters. With no decimal. Nice call. Let's do another one. 4.5 seconds minus 0.53 seconds. How many seconds do you have? Whoop. 3.97 seconds. Which number has the least amount of, which number is the least precise? The 4.5 or the 0.53? They both have the same amount of significant figures, but which one's the least precise? 4.5. So, is a 7 big enough to push my 9 to a 10? Where do I put that 1 at? Plus 3. So, I see what we did there? Okay. So, we got a little bit more time. I want to get us into scientific notation. I want to start us in it. Now, ladies and gentlemen, you're still just going to do, for homework, 5 down. So, all 5 is you're counting your significant figures. 6 to 13, you're taking the given number, rounding it to where you need to go. 14, you're doing functions. You're going to write down. You're going to put this in your calculator, or you're going to do it on paper, whichever one you want to do. You're going to add up, you're going to do whatever function that you need to do. You're going to write the calculator's units. Then you're going to write the final rounded number with the correct units. I'm looking for 2 things on question 14.
How does 9 work?
How does 9 work? All right, a bunch of those zeros. Do you think any of those zeros are going to be significant?
No.
Why not? I think you know what you're doing then already. You round to 1 sig fig, then 2 sig fig, then 3 sig fig, then 4 sig fig.
All right.
Scientific notation. Those who are in physics, you probably already got into scientific notation. Scientific notation, it's an easy way to simplify. Very large and very small numbers. And how we write scientific notation is we're going to take a number and we're going to write it in the power of 10. So let's pick a very large number to start off with. Let's choose 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. We're going to pick a super duper large number. Now, for those who kind of seen this number before, you may recognize it as is the number of atoms, estimated number of atoms in 1 gram of an element. We're going to refer to this as a mole eventually in the future. 6022 followed by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 zeros. That's a whole lot of zeros. And it's going to be an absolute pain if I have to write all those zeros every time. So, the first thing I want to do, I have some easy steps. I need to find the decimal point of the number. Where am I going to find the decimal point of this super duper long number? At the very end, right? I'm then going to move my decimal place all the way up. So 2, move, decimal, up, till decimal, makes a final number between 1 and 10. We're making this easy. So I move to 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. If I leave my decimal place here, is my final number between 1 and 10?
No.
20. Is it still between 1 and 10? 21. Between 1 and 10? Oh, I was off by a 0. Am I between 1 and 10 now?
Yeah.
So I'm going to add another 0 here because I was supposed to be 23. So that means that my number now is 6.022. So I move my decimal point to here. I'm now going to count every time I move my decimal. Now I wanted to count 23 times. So I had 22, I had to add an extra 0. So I moved it 23 times. That's my power of 10. So I grab another piece of paper. Give me a quick second here. So my base is 6.022. I moved it 23 times. So what's my power of 10? Times 10 to the 23. It's an easy way of taking a really, really big number and making it a lot easier for me to write. We're going to see if my power is positive. So if power is positive, large number. If my power is negative, I'm working with a small number. So let's do another one. Let's do a very small number. 0.000000047. First thing I want to do is do what, guys? Find my decimal place, right? Boom, decimal place. Next thing I want to do, where do I want to do that to that 0? To that decimal place. What am I going to do to it? I'm going to move it, right? 1, 2, 3, 4, 5, 6, 7, 8. Do I want to stop here at 0.47? No, I want to go to the next one, right? Boom. So, my base is 4.7 times 10. I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So is that positive 9 or negative 9? Negative 9. Anyone have any questions on our power? Okay. So, with a little bit more than 10 minutes left in class, I'm gonna allow you guys to work on your homework in here
Go.
because